Hello everyone, my name is Saez. Today I'm going to present the paper Repair It with Additive Manufacturing, an approach to the circular economy in architectural education. The paper is based on the teaching event conducted by the Chair for Structures and Structural Design at RWTH Aachen and the Cube Museum, the first design museum in the Netherlands. So I would like to start with this question: why repair it? We understand that during the life cycle assessment of a product, environmental impact is evaluated throughout its entire life cycle, from the materials extraction, materials manufacturing, parts manufacturing, assembly, until the products reach the user. So how can we extend the life cycle of a product? Our answer to this question is by extending its use or by repairing. So following up with this idea, we propose the course Repair It with Additive Manufacturing, where architecture students could select objects in need of repair, analyze why they got broken, redesign the missing parts, and finally produce them with the help of additive manufacturing. We divided the course in 3 parts: the video tutorials, the object hunting, the fabrication time, and of course the final submission day where we were able to discuss the results. Therefore, we decided to create some video tutorials on Fusion 360. They are really beginner tutorials and are for free via YouTube. We divided them into 4 steps: redesign and optimization. So once the students got the basics on 3D modeling from the video tutorials, we have to move to the next step that we called object hunting, where students had to look for objects in need of repair. In this picture we can have an overview of the kind of problems the students brought to the class. And we are going to see the first example here. And I had to disappear so you can really see the picture here. And the idea behind these different kind of angles was the possibility to cook different kind of sandwiches or paninis. Here we can observe another case, the shower head holder. In this case, the student used the material use optimization option available on Fusion 360. So he made a very rough first design and then apply loads in different parts of the piece in order to optimize the material use. In this another case, the student worked on a joystick. As we can see in the video here, he identified not only the problem of the missing part, but also another problem that we can observe here. It's also this part was not also working properly, so he decided to adapt an extra part to the actual missing part. And here we have another user-oriented design. So the student here identified problem from the additive manufacturing itself and turned it into a material-specific advantage. When the tension load was normal to the layer deposition, the part resulted to be weaker than when the tension load was parallel to the layer deposition. For that reason, he decided to print it vertically, and as a result, the properties of the object were optimized. So I would like to finalize with this quote: even apparently simple innovations can bring about dramatic changes, most of which cannot be predicted. We are convinced that the user knowledge has a crucial role in the decision-making process involved in design. This strategy unveils essential information that would not have been possible to predict in a more traditional design process. And of course, with the help of digital simulation software, we can predict where our designs could fail and optimize them. Thank you very much for your attention, and I'm pleased to hear your questions and feedback.